All right, I wanted to do a couple of examples from the 3-2 homework, which was for implicit differentiation. And there are three problems I wanted to work. You may have different numbers, but I wanted to work, these three as examples, okay? So number 10, find where the slope of the curve is defined, okay? So that's 5x to the fifth plus y to the fifth equals 5 times xy. Well, the slope of the curve is defined as dy dx, okay? And this question is asking you to find dy dx, which I'll find in just a second. And then it says it's defined everywhere, or there are spots where it's not defined. And I will show you how we need to fill this in, okay? All right, so I took the liberty of writing it already here so that I could have a nice piece of paper here to start with, okay? So I'm going to find the derivative implicitly. All right, so what the derivative here is, I take the derivative to the left side, and it'll be 25 x to the fourth plus 5y to the fourth dy dx. And I have to use the product rule on the right here. So the product rule is going to be first, if I use 5x as my first, so it'll be first 5x d second dy dx plus second, which is y, times the derivative of the first, which is 5. And now I'm going to be solving for dy dx here. So I just move everything over here. So I'm going to factor out a dy dx. And what's left is a 5y to the fourth. And since I'm moving this over, that will be negative 5x equals, and then this 5y stays over here, minus 25x to the fourth. And I can say dy dx is equal to 5y minus 25x to the fourth divided by 5y to the fourth minus 5x. Now I can reduce all of this by 5. So I can reduce this to dy dx is equal to y minus 5x to the fourth divided by y to the fourth minus x. Now what's really cool is that we have this incredible machine, the TI-89, that can actually verify whether our answer is correct. So let's see how we do that. We can go to F3, and instead of scrolling all the way down, we can scroll up, and you'll notice the impdiff command here. I'm going to click on that, impdiff, and then we just type in our equation here. I'll put it so we can see it in the screen here. So it would be 5x to the fifth plus y to the fifth equals, and it'll be 5x. Now this is really critical here. This is two variables being multiplied together. And when you have two variables being multiplied together, you have to use the multiplication symbol here, right here, okay? So it's going to be times y, comma, and then you have to give it the independent variable first, which is going to be x, comma, the dependent variable, which is y, close parentheses, and press enter. Now, the numerator says 5x to the fourth minus y, and I know this is opposite, but that's okay as long as the denominator is opposite, and you can see how our denominator is opposite. So that is true. This is what our derivative is. Now this derivative is going to exist everywhere except for when the denominator is equal to 0. So when this question says dy dx equals defined at all points, well, it's not defined at all points. It's all defined. So I would write in this box here y minus 5x to the fourth over y to the fourth minus x. Y minus 5x to the fourth. Okay, over y to the fourth minus x. Yeah, I copied it right. It's defined at every point except where I would just say here y to the fourth minus x equals 0. Right, so that's what this problem is looking for. This expression will be undefined when this is equal to 0. Okay, so that's example number 10. All right, number 25 is the next one. Now whoops, I'm on the wrong page. Sorry. 25 says, Find the slope of the curve at the points 3, 9 and 9, 3. Okay? And then it says, at what other point other than the origin does this curve have a horizontal tangent? And then it says, find the coordinates of the point other than the origin where the equation has a vertical tangent. Okay? So let's do it. Here we go. So first I have to find, if I want the slope at either of these 2 points, I have to find the derivative. So we're going to take the derivative implicitly here and say this is 3x squared plus 3y squared dy dx equals, I'm sorry, it's not equals. Now I have to use a product rule here, so this will be my first and this will be my second. So it'll be first, which is negative 28x, dy dx, which is the derivative of the second, plus second, which is y, times the derivative of the first, which is negative 28, equals 0, because the derivative of the right side is 0. So first d second plus second d first. Okay, now I'm going to collect the dy dx terms together and factor them out, and I get 3y squared minus 28x equals, I'm going to say this is 28y when I move this over to the other side, minus 3x squared. And so dy dx is equal to 28y minus 3x squared all over 3y squared minus 28x. And again, I'm going to verify it using our handy dandy calculators. We're going to hit F3, scroll up 1, hit impdiff, and then we're going to say x to the third plus y to the third minus 28x times, remember we got that times, y equals 0, comma, independent variable, comma, dependent variable, close. And we get 3x squared, minus 28, mine are flipped, but that's all right, my denominator's flipped. So so this is equivalent. All right, but now I need the slope at 9, or 3, 9. Okay, so I'm going to say dy dx equals 28y minus 3x squared over 3y squared minus 28x, such that x equals 3 and y equals 9. And we're going to plug that in. So that's going to be 28 times 9, because that's the y, minus 3 times 9, because that's the x, all over 3 times 81, because that's 9 squared, minus 28 times 3. All right, I'm going to multiply this out. And we get 28 times 9 is 252 minus 27 in the numerator, and I get 225. I'm going to try it again. 28 times 9 minus 27. Yep, I should be all right with that. Okay, and then it's going to be 81 times 3 minus 28 times 3. And that's 159. And I think these are divisible by something. And it reduces to 75 over 53. So that's the slope at 3, 9. So let's find the slope at 9, 3. So dy dx is equal to 28y minus 3x squared all over 3y squared minus 28x, such that x equals 9 and y equals 3. And that's going to equal 28 times 3 minus 3 times, it's going to be 81 all over 3 times 9, because that's 3 squared, minus 28 times 9, which almost looks like the flip of this. So let's try it. I'm going to put parentheses all at once. 28 times 3 less blurry here. 28 times 3 minus 3 times 81. Close the numerator. Divide. Open the denominator. 27 minus 28 times 9. Close the denominator. Enter. And sure enough, it is the flip of that. So it's 53 over 75. And it kind of makes sense, doesn't it? Because, I mean, we flipped the x and the y. All right, so this one we answered as part A. Okay? So this is the answer to part A. Part B says, the equation has a horizontal tangent at the point, and so it's looking for a point. Now, horizontal tangents occur when the slope is 0. So when the slope is 0. So the slope is 0. So we can say horizontal tangents occur when dy dx is equal to 0. Now, when is dy dx 0? That's when the numerator is equal to 0, which is when 28y minus 3x squared equals 0. All right, so what I'm going to do is say 28y equals 3x squared. So y equals 3x squared over 28. So I have two equations, which are x cubed plus y cubed minus 28xy equals 0, and y equals 3x squared over 28 that have to be true, right? Because first of all, the point xy has to be on the curve here, and it has to also fulfill this part of the derivative being equal to 0. So these are the two conditions. Okay, so let's do it. This is a system now. And it's not a linear system, it's a weird system. So I'm going to substitute in for y. So I'm going to get x cubed plus y cubed, which is going to be 3x squared over 28 quantity cubed minus 28x times y, which would be 3x squared over 28 equals 0. So simplifying, I get x cubed plus, well, this is going to be 27 in the numerator. X to the, you multiply this, x to the 6th over 28 cubed. So I'm going to just write this as 28 cubed because I don't know what that number is, but I know that it's pretty big. Okay, and these 28s, lucky for us, cancel, right? Minus 3x cubed, right? Because the x is multiplying, I get 0. Okay, I can simplify this expression and say 27x to the 6th over 28 cubed minus 2x to the 3rd equals 0. And I can factor out an x to the 3rd. X to the 3rd times 27 over 28 cubed, x to the 3rd, minus 2 equals 0. So I have a situation here where x equals 0, or what happens? This equals 0. So 27 over 28 cubed x to the third minus 2 equals 0. So I need another piece of paper. Hang on. So I'm going to solve this equation. 27 over 28 cubed x cubed minus 2 equals 0. So 27 over 28 cubed x cubed equals 2. X cubed equals 2 times 28 cubed over 27. Right? Because I'm multiplying by 28 to the third and dividing by 27. And then I'm going to take the cube root of both sides, and I'll get x equals, well, the cube root of 28 cubed is just 28. Cube roots of 2. Now the cube root of 27 happens to be 3, because 3 times 3 is 9, 9 times 3 is 27. So this is over 3. So my x is 28 over 3 cube roots of 2. Now it's not pretty, but it's a number. Now how do I find out what the y is that goes with this? Well, I'm going to take it back to the original system here and say, well, y has to be 3 over 28 times my x value squared. So this is going to be 28 squared over 9, because I'm squaring the 3. And if I square the cube root of 2, that's going to be the cube root of 4. And then I can cancel one of the 28s, and then I can get this to be a 3. And so y is going to equal 28 over 3 cube roots of 4. So my point's going to be, the x is 28 over 3 cube root of 2, comma, 28 over 3 cube root of 4. Now, those are very ugly numbers, but we're going to prove that it works, okay? So I'm going to take these numbers and I'm going to put them in my graph because I have a Desmos ready to go. This was our first one, which I thought was fun, okay? And this is our second one. This is the one where we were looking for horizontal tangents, okay? Now, we said the horizontal tangent's going to be, and I'm going to put the points under here, right? We said the point was going to be parentheses 28 times, we said, the cube root of, let's see if I can find a cube root. Miscellaneous. There we go. I want the cube root of 2 on the outside of this. Whoops, on the outside divided by 3. Comma. I want the same expression for the y, except I'm going to make it a cube root of 4. So copy. Paste. And I'm going to make this 2 a 4. Oh, look at that. It certainly looks like it's got a horizontal tangent right there. So if I were to write the horizontal tangent, I'm going to copy this. It would be at the y value, wouldn't it? So control copy. So it would be at y equals, control paste. There it is. There's the horizontal tangent line. And I'm going to make it a different color. Let's make it green. All right. That certainly looks horizontally tangent there. Right? So that worked. That's so awesome. I wasn't surprised. I knew it was going to work. Okay, here we go. So that's where the horizontal tangent is. And it says, the equation has a horizontal tangent at the point. And that point, you would type this in right here. It also, I know, look, I know the book is looking for that ugly radical, but at 0, 0, does it look like it has a horizontal tangent? And a vertical tangent, doesn't it? oops, 0, comma, 0. Whoop. Helps if I type things in the right order. Doesn't it look like it has a horizontal tangent here as well and a vertical tangent? But we'll get into that in the next part of the question, okay? All right. Okay, so our answer is this point here and 0, 0. Because remember, we said at x equals 0, it also had a horizontal tangent, okay? Now, I need to know when this equation has a vertical tangent, or this curve has a vertical tangent. So how do I find those? Well, how do we find those? I'm going to say that that's part C. And we say vertical tangents occur when dy dx is undefined. And when does that happen? That happens when the denominator is equal to 0, and that's at 3y squared minus 28x equals 0. And in this case, I'm going to solve for x because I'd like to not have square roots. So I'm going to say 3y squared equals 28x. So x equals 3y squared over 28, which looks remarkably like this, doesn't it? But I have a system because what else has to be true? Well, yes, it has to lie on the curve. So this is a system. So I'm going to use substitution to solve again. So I'm going to take this x and put it in where the y is. I'm sorry. I'm going to take this expression, and since this is x, I'm going to put it in with the x. So I'm going to take this expression, 3y squared over 28, and cube it, plus y cubed minus 28, and where I see x, I'm going to put, I should put 28 here, 3y squared over 28 times y equals 0. Okay, so let's simplify this expression. So 3 cubed is 27, y squared, or y to the 6, excuse me, over, I still don't know what 28 cubed is, so I'm just going to leave it as 28 cubed, plus y cubed. And these 28s cancel. Oh, wait. Yeah, okay, so then these 28 cancel, and I got minus 3y squared equals 0. So I get the same situation, which is 27 over 28 cubed, y to the 6th, minus 2y, this is cubed, sorry, cubed, right? Because 1y cubed minus 3y cubed is 2y cubes, negative 2y cubes, okay? Now I'm going to factor out a y cubed, and I'm left with 27 over 28 cubed, y cubed, minus 2 equals 0. And I have the same situation, so I get y cubed equals 0, which means y equals 0, and I'm solving it. And then I get 27 over 28 cubed, y cubed, minus 2 equals 0, and I solve that. So 27 over 28, y cubed equals 2, y cubed equals, this is 28 cubed, sorry, 2 times 28 cubed over 27, and I'm going to take the cube root of all this madness, and we get y equals, well, the cube root of 28 cubed is 28 again, and this is going to be the cube root of 2 over 3, which looks remarkably like, this y value looks like the x value we had up here. Okay, so I'm going to go this direction. So my points, so if y equals 28 over 3 cube root of 2, the x, I'm going to go back to my equation here, is going to equal 3 over 28 times 28 squared over 9 cube root of 4. Okay, this 28 cancels with one of them. This 3 goes away with this 1, 3, and I get 28 cube root of 4 over 3. So my point where I have a vertical tangent is going to be 28 over 3 cube root of 4, comma, 28 over 3 cube root of 2. So the point's just flipped. So we're going to see if it works. And obviously, right, 0, 0, which is what we expected when we looked at the graph. Okay, so here we go, going to the graph. All right, so 0, 0 worked. Now I'm going to put in another point here. The other point is going to be, we said the x is 28 divided by 3. Oops, I don't need that in the denominator. Actually, what I'm going to do to be even more efficient is go up here and grab the y here. Copy, because that's the x in this situation. Paste, comma, and then I'm going to grab the x, which is now the y. And look at that. That certainly looks like a vertical tangent's occurring there. I'm going to label that point. There it is. And I'm going to say x equals, control paste. Oh, no, then I need to change this right in here to this to 4. And you see how that works? It's tangent there, and it's a vertical tangent. Look at that. And as we noted, we have a vertical tangent at 0, 0. But I believe that this problem wants to have, it says type an ordered pair, type an exact, I'm sorry, I've got to be on the screen so you can see it, right? It says type an ordered pair, type an exact answer using radicals as needed. So it's looking for the radical answers like this, okay? All right, now what I'd like to also do really quickly is show you that you can solve this problem completely on the calculator, okay? And this is how you would do it. Okay, so the first thing is clear, F18. I'm going to clear all this out. Okay, so the first thing we would do on the calculator if we wanted to try to solve this problem on the calculator, help somebody the equation, is there's my equation. Okay, I need to find the derivative implicitly, which means I hit F3, scroll up, hit impdiff, there it is, and then I'm going to type in x to the third plus y to the third minus 28x, no, I hit 28 times, x times y, you must use the times, and it equals 0, comma, independent variable, comma, dependent variable, close. And there's my derivative. And as I noted, mine's backwards on the numerator, but it's also backwards in the denominator. That means if I were to factor a -1 out of this and a -1 out of this, it would match this exactly. So these are equivalent. Okay, so let's say I wanted to find the point or the slope at 3, 9. Well, I have an expression here, right? I have an expression here. So I can clear this out, hop up here, grab the expression by pressing enter, and I can use the such that bar here, such that. Now this is where it gets a little tricky. I have to define two values, don't I? I have to define both x and y. So I can use the such that bar. I can then say x equals 3. Well, that's the easy part, okay? Then we have to tell it something else. It's like we have to say x equals 3 and y equals 9. So we have to type in and. Now, in order to do this, there are two ways to get to and. There's the math key here, where you go second math, and do you see the test command here, which is number 8, and the and command is number 8. Okay, now I want you to notice that there was a space that the calculator put between x equals 3 and the and. You can type and if you like, but you have to do a space, which is above the minus sign. So you'd have to do alpha space, alpha A, alpha N, alpha D. And the D is above the comma. Okay, or you can just go second math, 8 for test, and then 8 for and, all right? And then what else do we want to tell it? Well, we want to tell it that y is 9. So we can go y equals 9. And so now we've said, I want you to evaluate this expression when x is 3 and y is 9. I'm going to press enter, and wow, there it is. Okay? It takes all the error out of us doing any calculations. So in 2 seconds, literally, well, maybe more than 2 seconds, we found the derivative of this, and then we evaluated it at a point. And what's really nifty is that now I'm going to evaluate it at another point. Well, I already have the statement here, so all I have to do is, and if I want to go to the end, you can press diamond. You see this right here means go to the end. And that's the right end. So I want to say, instead of x is 3, I'd like to say that x is 9. So I'm going to go back and say 9, and then I'm going to say back here and say 3 and press enter, and there it is. There's our 53 over 75. Okay, so we've got the derivative and the evaluation at those 2 points. And now I need to solve for when the horizontal tangents occur. Well, we can do this on the calculator as well. Okay, so I know that horizontal tangents occur when the numerator is equal to 0, which turns out that y equals 3x squared over 28. And I have a system. Well, here's the system. So if I were to plug in for y, I get an equation full of x's, don't I? So what we're going to do is we're going to have our calculator solve. So I'm going to press F2, which is algebra. F2, solve. Do you see the solve is number 1 on that menu? I press enter, and I want to solve this equation right here, the x cubed plus y cubed minus 28xy. So here we go, x to the third plus y to the third minus 28x times y equals 0. Now I want to solve that equation. If I substitute in for y, I'm going to have an equation full of x's. So I'm going to want it to be solving it for x. Okay, such that, here's my such that bar, I'm telling it that y is going to equal this. So I'm going to say y equals 3x to the second divided by 28. So I'm giving it the condition that y has to be here. So how did I get there? I said F2, solve this equation when y is equal to this. And I'm solving it for x. So here we go. I'm going to press enter, and you're not going to believe what happens. Here we go. Enter. Ooh, what was my syntax? Let's see. What did I do wrong? I did all of that, led all up to that, and then my syntax is wrong. Hang on. Oh, you know what I left off at 2? I heard you guys screaming from the back. Yeah, there we go. Mrs. Muller, you left off at 2. Right, there it is. Okay, I feel better now. Now I'm going to try it. Oh my gosh. Oh my gosh. Oh my gosh. Did I do that like in 2 seconds? I mean, that was faster than 2 seconds, I think. I got the answer. X equals 0. Wow. Well, there's 0. 0. Woo! Right? And then we get, what did we get? Over here, we got x equals 28 over 3 cube roots of 2. Look at that. And the calculator did it in 2 minutes. Or 2 seconds. 2 seconds. Pretty cool, right? Well, that's great. Well, that's the x. I still have to do some algebra, Mrs. Muller. No, you don't, because I know what x is now, right? So I can clear this out, And I can say, I want to know what this expression is. What was x equal to here? Or y is equal to 3x squared over 28. So you can go 3 divided by 28 times x to the second, such that x equals, and I'm going to go up here and I'm going to grab this, and I'm going to get rid of all the stuff I don't need, right? I don't even need that right there. So I'm going to get rid of this. So what did I do? I just grabbed this expression and got rid of the 0 and all of that other junk. And then I can say, evaluate. And there it is. X 2 to the 2/3 is the cube root of 2 squared, which is 4. So that worked. You see that? So we did that on the calculator very quickly. Okay, when it took all of this algebra to solve. Okay, now I'm going to stress to you that you need to be able to solve this both with the calculator and without. Okay, because you don't know what section this is going to be on, whether it's on the calculator section or it's on the non-calculator section. Okay, so that's pretty awesome. Now let's find out where the vertical tangents occur. Okay. Well, the vertical tangents occur when the dy dx is undefined. So we came up with this expression, x equals 3y squared over 28. So what are we going to do? We have a system here. And when I plug in for x, I get an equation full of y's, don't I? So I want to solve this equation for y when x is equal to this. So let's do that on the calculator. We're going to hit F2 for solve, and then I'm going to type in x to the third plus y to the third minus 28x times y equals 0, comma. I'm going to solve it now for y. Remember, because when I use this substitution, I'm going to have an equation full of y. So I'm going to put a y here, close, such that x equals 3y to the second, I promised to type the 2 this time, divided by 28. Here we go. And we got y equals 0, which is what we got after we did all of our little calculation. Y equals 0, and we said the 28 cube root of 2, and there's 28 cube root of 2. Okay, now what if I want to know what the x is that goes with this? I'm going to clear this out, and I know that x has to equal 3y to the second divided by 28, and I'm going to go such that, and I'm going to come up here and grab this expression and get rid of everything in front of the y equals, and then press enter. And there is our x value that we found. Amazing! This calculator is amazing. Okay, so I wanted to show you that you had the ability to do that. Okay, all right, last one. Number 26. Yeah, that's number 26. Because this is the problem here. Okay, so number 26 says the line that is normal to the curve at 5, 5 intersects the curve at what other point? Okay, so in order to know when, well, first of all, the normal line is going to intersect the curve at 5, 5 because it's tangent and normal there, right? So I need to find the normal line. So let's find the normal line first, okay? Through 5, 5. Well, that's an easy enough thing to do. We're going to take the derivative of this implicitly, which will be 2x plus, and this is first and this is a second, 2x dy dx using the product rule, plus second, which is y, times the derivative of the first, which is 2, minus 3y dy dx equals 0. Solving for dy dx, I'm going to factor out first. I get 2x minus 3y equals negative 2x minus 2y. Dy dx is equal to negative 2x minus 2y all over 2x minus 3y. Okay, now if I wanted to get rid of the negative up here, I could just, flip these two, All right, so just for verification's sake, I'm going to check this out to make sure we're right before we keep going. I can get F3, implicit differentiation, and I'm going to type in x to the second plus 2x times y minus 3y to the second equals 0, comma x comma y close. Let's see what I did. This is 2x. First d second plus second d first. Oh, you know what? I can't multiply. You guys are like, Mrs. Muller, you forgot to multiply. That's 6 here, isn't it? Duh. That's why I checked my answer, which is good, right? This is a 6 because 3 times 2 is 6. Oh my goodness, I can't even do the power rule tonight, okay? All right, so I can reduce this all by 2, obviously, which will be negative x minus y over x minus 3y. Yeah, there we go. So we confirmed that, which is nice. All right, so I'm going to find the slope at 5, 5. Okay, so dy dx is equal to negative x minus y over x minus 3y such that x equals 5, y equals 5. All right, and we get negative 5 minus 5 over 5 minus 15. Right? Negative 5, 5 minus 15. Okay, so we get negative 10 over, goodness gracious, that certainly looks like negative 10. So the slope is 1. So if the slope is 1, this is the slope of the tangent line. The normal slope will be negative 1. So my normal line through 5, 5 is going to be y minus 5 equals negative times x minus 5. Because we're using the same point up here. Okay, so let's distribute. Y minus 5 equals negative x plus 5. Y equals negative x plus 10. Okay, so this is the normal line. And we already know it intersects here at 5, 5. I'm sorry, at 5, 5. So they're saying that this line will intersect this curve at another point, which means this is another system because it has to be on this curve and this curve. So this is a system. So where we see y, we're going to plug in negative x plus 10. So we're going to get x squared plus 2x times negative x plus 10 plus 3 times negative x plus 10 quantity squared equals 0. So we get x squared plus, I'm sorry, it's minus because it's a negative x here. Minus 2x squared plus 20x. If I distribute these. Plus 3 times, I'm going to expand this. So it's going to be x squared because negative x times x. Minus 20x plus 100. I forgot the 1. Equals 0, right? If I factor that this is x minus 10. Quantity squared, or, yeah, that works. Okay, so we get negative x squared plus 20x plus 3x squared minus 60x plus 300, nice big numbers, equals negative 2x squared minus, that's going to be minus 40x. No, this is not negative 2x squared, it's a positive 2x squared. Right, because this is negative 2x. This is 2x squared. Negative x squared plus 3x squared is positive 2x squared. This is 20 minus 60, which is negative 40. X plus 300 equals 0. I can factor out a 2. I get x squared minus 20x plus 150 equals 0. The factors of 150 that might add up to 20. This would be 15 and 10, right? Or what else goes into 150? 30 does, right? $30 and 5 won't work. 150 divided by 25. 25 and 6 won't work. All right, for the purposes of this video, we're going to see if it factors by hitting the factor command. X to the second minus 20x plus 150. That doesn't factor its prime. Let's make sure I'm right here first before we do this. X squared plus 2x times y, which is negative x plus 10, plus 3 times this quantity squared. So we get x squared minus 2x squared plus 20x, I'm all right with that, plus x squared minus 20x, and that's squared, equals 0. So when I multiply the 3 in, I get 3x squared minus 60x plus 300. And I get negative x squared plus 3x squared is 2x squared minus 40x plus 300. Okay. So that means we say that x has to equal the opposite of b, which is 20, plus or minus the square root of 20 squared, which is 400, minus 4 times 1 times 150, all over 2a, which is 2. So this is x equals 10, plus or minus, that's going to be 400 minus, oh, it's negative. I have the right equation, right? 3y squared. All right, so here we go. X to the second plus 2x. I want to expand this, right? Here we go. F2 expand. And I did this right? Let's see, did we do the slope right? That's negative 5 minus 5 is negative 10. 5 minus 15 is negative 10. That's 1. So I'm all right with that. And that distributed and that added. Okay, so then here must be the problem. Or we've got a problem. X squared plus 2x times parentheses negative x plus 10 plus 3 times parentheses negative x plus 10 raised to the second, close. I shouldn't doubt my algebra, And 300 divided by 2 is 150. Opposite of B, 20 squared is 400 minus 4 times A times C. All right, I see what I did. I found it. I copied my equation wrong, right? This is negative. This right here is negative 3y squared. I'm sorry about that, folks. So I'm like, I have to have a solution. Modeling humanity every day, right? Here we go. Helps if I have a negative sign here. Oh my goodness. Okay, so this is going to be negative x squared. Let's try this again. Plus 20x minus 3x squared plus 60x minus 300 equals 0. Yikes. Jinkies, right? Okay, so that's negative 4x squared plus 80x minus 300. Let's just triple check this. This is negative x squared plus 20x, negative 3x squared minus 20x times 3, which is plus 60x minus 300 equals 0. I'm going to factor out a 4, negative 4, and I get x squared minus 20x plus 300 over 4. $75 equals 0. All right. I'm liking this much better. Holy smokes. Okay, here we go. This is x and x equals 0. So x and 5 and 15. So this is negative 5 and negative 15. And the inner product is negative 5x. The outer product is negative 15x. When you add them together, you get negative 20. And negative 5 times negative 15 is indeed 75. So I knew I had to have a factor of 5 at least. Why? Because this 5, I know I have a point on there that's 5, 5. So this makes sense that I'd have a 5 here. So I have x equals 5 and x equals 15. Okay, so now I have to find the y that goes with that. Well, if I know that y equals negative x plus 10, and I know that such that x equals 15, I get negative 5, right? So that point's going to be 15, I'm sorry. X is 15, and the y that goes with it is negative 5. Let's just think about that real quick. Negative 15 plus 10 is negative 5. Okay, so we're going to prove it to ourselves because I do have this one also on Desmos. And I really sincerely apologize for that algebra. But the good news is that you can speed through me making that mistake after you guys have been saying, but Mrs. Muller, that was a negative. I know, you were right. There it is. There's my curve. And I need to get rid of my labels here for these. Boom. One more label I'm going to get rid of. Where's the other label? Here it is. Okay, so there's my curve. And we said that the point is 15 comma negative 5, right? And look at that, it's on the curve. And so was our 5 comma 5. They're both on the curve, okay? All right, well, like I said, I'm sorry about this last problem, but you know, at least you have an example. And so let's do it on the calculator, right? Well, so what did we do really quickly? We found the derivative, right? And then we found the slope of the tangent line was 1. And we know that the normal line slope has to be the opposite reciprocal, which would be -1. So I created the normal line, which is y minus 5 equals negative x quantity x minus 5. Then I solve for y, and now I have a system because the points have to both lie on the normal line in this question and on the curve. So how do we solve that on the calculator? Well, if I were to plug in for y here, I get an equation full of x's, don't I? So I can have my calculator solve this equation, x squared plus 2x times y minus 3y to the second equals 0. I can have it solve for what variable? Well, when I substitute in, I'm going to have an equation full of x's. So I want it to solve for x such that, right, y equals negative x plus 10. And this will be a lot easier than me not taking care of this pesky negative. Anyway, and so you see that we get x equal 5 and 15 here, which is what we got, right? And then we find the y that goes with it and all of that. It's been a long Friday afternoon, and I just, wanted to make sure that you had these 3 examples worked out so you can maybe do your homework quicker. All right. So forgive me for the last one, and we hope you have a great day. Thanks.